Okay. Okay, good afternoon. It's my pleasure to present our team, Graphene Plasma Technology. And here are the members of our team. I am Michael Kedar, Associate Professor at School of Engineering. With me here is Alex Shashurin, who is a research scientist at School of Engineering. Louis Beitraga, who is master student at School of Engineering. And Jay Donahue, who is a junior undergraduate student at School of Engineering. Our focus is graphene. What is graphene? Graphene is two-dimensional, one layer of carbon. In fact, it's the most basic allotropy, or most basic form of a carbon material. And you know, the graphite, the material that we use in day-to-day life, is nothing else as many, many layers of a graphene. Despite the fact that the graphene was predicted theoretically, it took a long time, a lot of effort to actually obtain this material, extract from graphite or exfoliate. And this is why successful exfoliation of graphene landed into a Nobel Prize in Physics not long ago in 2010. So why graphene is a wonder material? And here's why. Because it has very high mechanical properties. In fact, it's the strongest material ever. It has very good electrical and thermal conductivity, and the surface area, it's enormous. You can imagine 2,500 meters square fit into just 1 gram of that material. So for about 5 years, we were working in my lab on synthesis of different carbon nanomaterials in plasmas. And as a result, we discovered the way to synthesize graphene. And that was a basic research, but it led to validation of this technology and a patent. So we use plasma to obtain this material. What happened is, in the vacuum chamber shown here, we ablate solid graphite, and then through the plasma state we synthesize graphene material, and this single setup is able to produce about 10 tons of materials per year. And it's amenable for scaling. In fact, you can scale by factor of 10 to 100 by simply adding more chambers. So why using plasma to synthesize graphene as opposed to existing technology, which is chemical exfoliation? And these are some representative of this technology, different companies which are our direct competitors. So first of all, the time scale. It takes about a fraction, in fact, 1,000 of a second to produce graphene, the same amount of graphene that takes about half an hour in the case of chemical exfoliation. So this process is really the only one that allows mass production. Right, that's number one. The production happens on at very low price, about $100 per kilogram. And because it happened in the plasma state, it has ultimate control of synthesis technique, different parameters that can affect production rate, properties of the graphene, and quality of the graphene. But most importantly, this is direct conversion of solid graphite through the plasma into the graphene. And as a result, there is no byproduct. And there is no byproduct, there is no exhaust, which makes this technology green in the nature, as opposed to chemical exfoliation that require mitigation of chemical exhaust. And now I am turning stage to Jay, who will talk about application of this product, and in particular, a derivative of our raw graphene product that we called GAR21.
So our team has found a way of producing graphene at a much lower cost, and we've called this graphene GAR21XX. And GAR21XX is being marketed towards the plastic additive industry. And it really dramatically increases the range to which plastics can be used. And one application you might see would be flexible, bendable touchscreens, coating of biomedical materials in the plastic, and there's many more applications. So when GAR21XX is added to plastic, it dramatically increases the strength. If 1% of the total weight of the plastic is GAR21XX, it'll increase the strength by approximately 10 times. And this would allow plastics to be implemented in a lot of situations where you currently use metal. And this would dramatically lower the cost of manufacturing and the material cost, and ultimately the cost of the final product. Also, it increases the electrical conductivity of plastic. Electrical conductivity in plastic is important because you don't want small electric shocks to occur in many situations. And situations like that are in airplanes and cars, where small shocks can cause damage to wiring. And later on, they might even be, plastics may even be used in engine parts. And small static shocks in that case could set off fuel, which would cause explosions, which causes large problems. So our primary objective is to market towards high-strength plastics, thermally conductive plastics, and electrically conductive plastics. And just to give you an example, if you were to supplement our product for the wiring on a Boeing 747, you would reduce the weight by a few tons. And this would drastically lower the cost of fuel for the plane, and would also be much easier to implement.
As we already mentioned, technology has been validated, but most importantly, market has been validated. And now I am turning the stage to Alex, who will talk about market validation.
Thank you. So in 2012, in GW, we created here a team with Michael Kader, Dr. Andy Graves, and myself. And we went through the program funded by National Science Foundation. It's a relatively new program called iCorps. And what it is, it's basically 2 months of market evaluation. We work with serial entrepreneurs, successful serial entrepreneurs, who made us a lot of critiques. And we try to answer many questions like what's our target market, who are our customers, how we can survive, how we generate revenues, and how we are going to operate. The most important point of this validation was that we not just sit in an office and review literature. We went out of the building and talked to companies. We talked to 65 companies. Here is an example of companies we talked to, and some names that you have, just few of them. Each of those companies play a different role in the chain, but together it helps us a lot to understand our place on this market and how we can proceed with our product. This is probably one of the most exciting examples we had, examples of conversations we had with company XG Sciences. They committed in a letter to purchase several tons of our material if it satisfies certain technical requirements. And here is our market. As Jay already said, this is plastic additives. The big market is plastic additives for 2012, $42 billion. Our part is inside a segment of $8 billion, which is reinforcing additive. GAR21 is here. And we are targeting, certainly with ramping up in production, it's larger than $1 billion opportunity. This is operation model. We have compounding company here, which is buying from 2 sources. They buying GAR21 from us. They buy raw polymer from polymer manufacturer. They mix it, make their composite part, and take it down the chain to the manufacturer and final product and final customer.
We talk about technology validation. We talk about market validation. And now let's talk about finances.
All right. So I would like to start by mentioning several assumptions that support our financials. 3 general assumptions. So the first one is that the reinforcing plastic industries will remain interested in reducing the cost of production. The second one, the interest in conserving non-renewable materials and using materials that offer environmental benefits will remain strong. Third one, we will have access to $2,345,000 in capital investment. As a financial assumption, the cost of goods sold, 20% of net sales, the price of our product, $100 per kilogram, and just the timeline that is shown in the next graph. The development of our project requires 3 different phases. So the first one is just for company and product development. The second one, just to find the final design of our production plant and to initiate production. And the third phase is just for manufacturing and scale up. So we are planning to start the first phase by July 2013. So a lot of money is included in this project, in this phase. So by winning this competition, we will receive incredible benefits. So we're going to take the $25,000 to fine-tune graphene to produce GAR21 at lab level, and also to obtain important data to adjust our financial projections. More importantly, we will benefit from the prestige this award will give our team, so that investors will look at this project in a more attractive way. Now, the second phase starts November 2013, and working concurrently with the phase number 1. So we will develop 3 different tasks. One is just to design and construction of our production plant and to retrofit facilities. The second is just to design, select, and evaluate key personnel for GPT positions. And the third one is just to buy equipment for quality control, for storage, for offices. The third phase starts on March 2014, and just by producing GAR21 and increasing the production to match the sales strategy. By August of 2014, no more investment is required, and then GPT start collecting revenue and returning on investment. So this process takes about 22 months from the beginning of the project, about 58 tons of GAR21 produced and sold. Calculation includes costs, the investment, and the sales. Now, the key in our sales strategy is customers. We are planning to acquire a small number of customers at the beginning, only 12 in the first year of production, and about 120 in the fourth year of production, achieving almost the maximum capacity of our production plant. So we are planning to deliver technical assistance and periodic visits that will be the key in our strategy for building an unbreakable relationship with our customers. Now, if an investor would like to be part of this novel project, or a group of investors, they will not only receive their investment back at the beginning of 2015, but at the end, they also will receive some profit. So about 1 million if we are talking about 30 or 35% ownership. In 2016, about $5 million, and 2017, about $10 million. Next year's a bit more, over $10 million. Thanks.
Okay, so where we are and what's next? Technology has been validated. More importantly, market has been validated by talking directly to customers, in fact, to about 65 customers. New green renewable technology is proposed, but not just technology. This is really technology that can make enormous impact on prime industry sectors such as automotive, aerospace, and consumer electronics. What's next? We are about to start designing our pilot facility. We are in the process of appointing board of directors of our company. And for the phase 1, as we described, it's required about $450,000 of investment. We hope to collect $25,000 from family friends, and hopefully $25,000 as a winner of this business plan competition. Thank you so much. We are ready to take any questions.
Make the line.
What's been some of the feedback you've received from the 65 clients you've been speaking with regarding this product?
So main feedback, and this is what we're looking for, are the parameters of our product. What kind of quality of graphene they expect it to have, and this letter of intent that we received is specifically, say that they're ready to buy 3 tons of our material within the next year if we satisfy certain parameters. So the most valuable impact we got from these interviews is a quantity and quality of material, and also it allows us to assess what is a prime kind of main application of this material, where is the main market right now.
Can you talk about your production and distribution scalability?
Yeah, so I mentioned a little bit. So one chamber, which is a lab-sized chamber, right, will allow us to produce about 10 tons of material. And by just scaling up by factor of 10, we can basically, take entire world market, which is right now about, several tens of tons of material. And the main problem why, market is waiting for this product because chemical exfoliation of process, which is a mainstream right now, is very slow. They just can't supply enough of material that market requires.
A little bit more information about your patents or patents pending? And
yeah, so there is a patent application. It's pending patent that's filed through George Washington University, and we have some agreement that our company will obtain exclusive license.
So who's the lead business person on the team?
Well, so we have, business advisor. Main business advisor is Dr. Andy Graves, who is in the audience. And we have 4 other business mentors that assigned to our team.
But like the day-to-day hustler, who is it?
Well, there are a few people, we are all here, right?
Right.
So, Louis made all financial calculation. Jay is mostly responsible for interaction with customers. Alex is a technical person, and myself is also a technical person and kind of oversee the entire project.
You got a quick question here?
Okay, the GAR 21, is that strength, and so what kind of strength is it? You mentioned the GAR 21XX?
What strength is it?
Yes.
Strengths, you mean
He's
in
asking-
terms of mechanical properties?
Yes,
Well, so this is derivative of our original graphene, and depends on the level of functionalization, and depend on the type of a plastic application. It will have variety of properties. So it will all be driven by a particular application. This is why it's XX. So it can have different modifications, but it's all based on our raw graphene platelets that we develop in our facility.
Great. Thank you very much, guys.
Thank you.
Very good.
Thank you so much.
Thank you. Thank you.